harnessing sunlight, there are other possibilities in which energy from the environment can be harnessed. And one type of device is called a thermoelectric device. And what that particular device does, in principle, in the construction and in the interior of the device, it is relatively similar to our solar cell, but its function is slightly different. Instead of harnessing light, like in the case of solar cells, what the thermoelectric device does is that it harnesses thermal energy from the environment. And then this thermal energy through the device itself is transformed into electrical energy. And again, thermoelectric devices have been around for quite some time, but their efficiency is relatively low. And one of the advantages of using nanostructured materials for the development of thermoelectric devices is that again, we can decouple conduction of phonons, which are carriers of heat, and conduction of electrons, which are carriers of electricity. And one way to increase the efficiency of thermoelectric devices is by decoupling these two components. One of the requirements is in the material is to have relatively high electrical conductivity but relatively low thermal conductivity. By using nanostructured materials and, for example, changing the morphology and the shape of nanowires, we now have the ability to decouple these two things from each other. And in terms of the thermoelectric devices, there is still much room for the improvement, and there are many things that we still have to learn in order to produce efficient thermoelectric devices. In a practical sense, you can think about the fact that there is a lot of waste thermal energy in our surrounding. I mentioned, for example, previously that you can have light sources, so the devices in which their function is to produce light. But however, they also produce thermal energy. So you can imagine that this thermal energy that otherwise would be wasted as heat, we could harness that energy and produce additional source of electrical energy. Also, cars themselves produce a lot of thermal energy. The engine itself is relatively of high temperature, and you can think about covering this type of devices that produce thermal energy. You can harness that and convert it to electricity, such that you, for example, internal functions of the car or even lights of your car are now using the electrical energy that is produced from the otherwise wasted heat. The question of combining thermoelectric devices to harness the heat and then solar energy to harness the light is particularly exciting. And there are many examples. One example would be particularly car, where these two things could be combined. One of the questions right now is the efficiency of these devices. So we still have to work on the design of thermoelectric devices that would be efficient enough such that their cost really justifies their function. But certainly in future there are ways and there are paths toward designing cars that could function in that particular way. The other question is in which kind of environment this car would function, whether there is enough sunlight, whether there is enough heat, etc.